have a cast iron rotated cast iron this coupling. Here power is given 15 kilowatt. Then RPM is given. Also some shear stress, crushing stress, etc. are given. The first step is we have the first step here, that is P is equal to 2 pi n T by 60. Here P power is known, RPM is known, from which we can find T. Second step is this one, T into service factor is equal to TS. So we can find that one. Then third step, TS is equal to pi d skew by 16 into tau s. So here tau s, it is the shear strength of the shaft that will be given in the, or shear stress of the shaft that will be given in the question. And TS, it is known, so we can find the D, diameter of the shaft. Then for the fourth step, what we should do is, here L, length is equal to this one, 1.5D. So from here we can find the length. Then the fifth step is D1. D1 is equal to 2D, from which we can find the hub diameter. Then sixth step is checking whether this hub diameter and all is correct. So for that, TS is equal to pi by 16 D1 raised to 4 by D raised to 4 by D if it is cast iron, or TS is equal to pi by 30 to D1 raised to DTS if it is steel. So here we are having cast iron. So here D1 we have found, D we have found. So we will substitute all those things and we will find this tau C1 and check whether this tau C1 it is given as allowable shear stress for cast iron, that is for flange. So we will go and check whether this tau C1 is less than that given in the question. In the given question it is given shear stress for cast iron is 8. So we will check whether in the present thing tau C1 is less than 8 or not. So after that, what we do is we go for the seventh step, that is this one. Here we are going to find the number of bolt. So new heading comes bolt. So there I is equal to 1 by 40 into D plus 2. So we will substitute all those things and find I. So this one is I. So then what we are going to do is, some of the eighth step, this one is the eighth step, where D2 we will find D2. D2 is equal to 3D. And in ninth step we will find D3. D3 is equal to 40. In 10th step what we will do is, so here it is the 10th step. In 10th step we are going to find this one, diameter of this bolt. So what we do is, we have tau here, and tau is actually the shear stress of bolt, and that will be given in the question. Pi is given, I is we have already found I here, number of bolt, and D that should be found, D2 we have found, so we will get D from this one. So after 10th step we will be moving to this step T, that is new heading comes for flange. We will be, for flange we will be finding flange thickness. Flange thickness is equal to T is equal to 0.35 D plus 9 mm. So we will find flange thickness. Then 12th one, the torque capacity of this. So we have flange thickness, that is T. We have D1. We have to check it whether those are correct or not. For T is equal to tau pi D1 square by T. So here we have to find a tau. So we will substitute D1, we will substitute T, and we have this one is TS actually. TS we have found. So from which we will get tau, and we will check with the question. In the question, here it is given that for the given this one, in this particular thing it is for bolt it is given shear stress for bolt it is 40, and we will find tau and we will check whether it is less than or greater than our given tau. Then in the 13th step, here now we are going for key design. In key designing, the first one is thickness of key, that will be is equal to width of key, and that will be equal to D by 4, shaft diameter by 4, and it will be for a square key we are writing all those things. Now length of key is equal to length of hub. Length of hub is equal to 1.5D. We have already found, or we can find here once again. So 1.5D. Now what we will do is, TS is equal to length into length of hub into width into tau into D by 2. Here L we have found, length of key is found, W width of key is found, tau it is unknown or we are not taking it, D by 2 diameter of the shaft by 2. TS is known, from which we will find a tau, and here we will get this shear strength for key, and we will check it with that of given shear strength. Now here we have crushing strength. Crushing stress is also given in the question, but we will find sigma C with respect to given L. L is length,
length of hub T, thickness of hub by 2 into sigma C. Sigma C is the thing should be found, D diameter. TS is given, from which we will find sigma C and we will check it to the given. At last, if everything is okay, we will conclude.